All right, let's take a look at this problem number 4. The directions are still the same, that we're identifying the intervals over which this function is increasing or decreasing, and we also want to use the graph to identify any symmetries and determine if this function is even, odd, or neither. So like the first problem, we see that the graph is going off of the page here, and we are to assume that continues on forever. So I can put arrows there and argue that they have, well, here, I'll just do it again. I can argue that this is going on up forever. Now I also notice that as I'm moving to the left, it's going up. As I'm moving to the right, at some point in a later skill packet, we do look at what we call asymptotes. Sometimes there'll be a dashed line on the graph to help us read a graph, and when we see that dashed line, we're to interpret that the graph gets closer and closer and closer but never touches that. It's just a visual aid in helping us read the graph. We don't have that here, so even though it's very steep and it looks like it's almost going directly straight up, it's not going just straight up. It's also going slightly to the left, and over here it's going slightly to the right, and that would continue on forever. So let's look and see and identify where this function is increasing. If I start here at this vertex, the x-coordinate is 2, and if I move to the right, as I move from left to right, what's happening with the y-coordinates of this graph. So pick any 2 points that are in this interval. As I move to the right to stay on the graph, I also have to be moving up, and that's indicating that those y-coordinates are increasing on this interval that I've chosen. Well, we here at this vertex, the x-coordinate is 2, and that continues on until I hit this arrow, and I can indicate that arrow is representing that x is going towards positive infinity. So on the interval from 2 to positive infinity, our function is increasing. If you pick any 2 x's that are in this interval, then we guarantee that as x increase, the y's will also increase. Now, let's take a look at if it's decreasing and where it's decreasing. So again, at this vertex of 2, as I move from left to right, and I shade this portion of the graph, then if I pick any 2 points in that shaded region, as x increases, as I move to the right, I have to be moving down to stay on the graph. So that's the down, those y-coordinates are decreasing, and the y-coordinates are the output of the function. So on the left here, I interpret that arrow as going to infinity, and since it's going to the left as it's going up, the x values are getting smaller, and that arrow is to be interpreted as negative infinity. Then these x are increasing, these x's are increasing because I'm moving to the right until I get to this positive 2. So what we've highlighted here in green, the output of this function is decreasing on that interval of x's. Alright, so now let's look at it and determine if we can identify symmetry to determine whether this is an even function, an odd function, or neither. So I'm going to erase this just so I can see my graph a little bit better. And I notice that this looks to be the squaring function. It looks to be the graph of a parabola. And I know that when we've studied parabolas are symmetric. There is even, we're interested in the axis of symmetry when we study parabolas. And I can sketch that axis of symmetry because it goes through the vertex. So I do have symmetry here with respect to this axis. The left-hand side is a mirror image of the right-hand side. But that is not an even function. I need this axis of symmetry to be on the y-axis to say that this function is even. So yes, it's a mirror image. The right-hand side and left-hand side are reflections of each other, But the mirror is not the y-axis. This axis of symmetry is the line x equals 2, not the line x equals 0, not the y-axis. So this is not an even function. And I can easily see that this is not an odd function, because remember, odd functions have symmetry with respect to the origin, a rotational symmetry. And if you put your pencil on the origin and you spin the graph about that point, so if I put my pencil right there at 0, 0, and I spin the graph 180 degrees, do I get the same graph? Well, not even close, because this parabola is open and upward and this one's open and downward. They're not the same. So it's easy to see that it's not odd either. So since it's not even and it's not an odd function, we're saying it's neither. It's neither even nor odd. Alright, so I hope that helps.